Welcome back. In this recording, we are going to learn all about levers. This picture is here just to put you in a good mood with the pictures of some cute kids because we are in that difficult muscle physiology section. So let's back up from muscle microanatomy and put muscles, as in the entire muscle, to work. And in order to understand that, let's go back to some grade school concepts we learned about some simple tools to help us do work. One of those simple tools was a lever. Okay. And basically a lever, in its most simplistic thing, is a rigid bar that has a pivot point. Okay. And that pivot point is called the fulcrum. And so that rigid bar can then rotate on that fulcrum. Okay. So based on the location of where that fulcrum is, here or here or here, and where we're going to be putting the weight versus where we're going to be doing the work, okay, we can move parts around and develop 3 different types of levers. So taking that concept and putting it in humans, what we have to realize that it's the muscles that are moving the levers, okay? And when we talk about muscles, we are actually talking about their attachment. So where the tendon is attaching is going to be moving that rigid bars. So in the body, the fulcrum is the joint, the elbow, the wrist, the knee, okay? Whereas the effort is the muscle that's contracting, and the location of the effort isn't the location of the muscle belly, but it's the location of the tendon's attachment relative to the fulcrum and the load. The load being, what is it we have to move? Okay. So let's put that into work. And we're going to, and the reason why we have these levers is because they're mechanically an advantage. So you can do more work with less effort. So in this particular diagram, the fulcrum is right in the middle, and we are going to have the load sitting at one end, and we are going to have the effort happening at the other. And so we measure the distance between the fulcrum and the effort, and we also can measure the distance between the fulcrum and the load. Another word for the load is resistance, okay, as in this picture. Okay. And so we end up with what's called the effort arm and the resistance arm. So for mechanical advantage, what we do is we take the total length of the effort arm and divide it by the length of the resistance arm. So if the length of the side doing the work is longer than the length of the side with the weight, that enables us to give more force. So more force is going to be produced, but that load will travel less or travel at a lower speed. On the other hand, if the effort arm is shorter than the resistance arm, then it will move further or move faster, but less force is required. So those are the mechanical advantages. So if you're going into kinesiology or physical therapy, you're going to have courses on biomechanics where you're going to be looking at these things specifically, where you'll be looking at multiple muscles that do the same action, and you'll be looking at the differences of their effort arms to the resistance arms to figure out which one has the mechanical advantage for certain actions. So that's what I've written about down here at the bottom. When 2 muscles act on the same joint with the same action, for instance, there are 2 agonists doing the exact same action. If their attachments are different lengths, then they are going to have different mechanical advantages. If you have a high mechanical advantage, that means it's easier for you to overcome the inertia. It's like driving in a low gear in your car. But if you have a low mechanical advantage, less than 1, that means you have more speed. It's like driving in a higher gear for those who are used to how cars work. So let's look at our 3 different classes of levers. The first class lever is the one we have been talking about so far, okay? Where we have the fulcrum in the middle, we have the load at one end, and the effort at the other end. Now, does this remind you of anything from your childhood? I hope it does, because this is your teeter-totter or your seesaw, okay? Where one person is pushing down to lift the other person at the other end, and your pivot point, your fulcrum, is in the middle. This is also the exact same thing that happens when you are cutting paper or cardboard or anything with scissors, where here you can see what your hands are doing. That is the effort. And then in the middle, you have the fulcrum, and at the other side, you have the blades cutting whatever it is you are attempting to cut. All right. So those are the examples in real life. What's an example in your body? The atlanto-occipital joint. So stop for a second and understand what those words mean. Atlanto is referring to the atlas, which is the first cervical vertebrae. Occipital is your occipital bone. So specifically, this joint is between facets on the atlas and the occipital condyles. And so that's what's in the middle. Okay. Posterior to that, you have those neck muscles you've learned about. Your semispinalis capitis, your splenius capitis muscles. They are doing the effort. And then the load is the weight of your head. Okay. So this explains why when babies are first born, their heads are like this, because they have to develop those posterior neck muscles to go in the extended or upright position. So that is your first class lever. Now, to get to the other classes, we need to move these things around, which means the fulcrum has to move, okay? Because if the fulcrum stays in the middle, it doesn't matter if you have the load on one end and the fulcrum on the other versus you do it like that, they're exactly the same. So we have to take that fulcrum that was in the middle and move it off to the one side. And then we will have the load and the effort, and then we will move those around, and that will give us our second and third class levers. So in the second class lever, I have 2 different pictures because I want you to realize this is the exact same lever. It's just one is looking at it from one side and the other is looking at it from the other side. So the so the fulcrum has to be at one end. And in a second class lever, what we put at the other end is the effort. And so the load is in the middle. Can you think of any place in your life where you've ever seen something like a second class lever? So most students say, no, I can't think of anything, in which case I ask you to think, okay, what if you were working in construction or yard work and you wanted to move a lot of heavy stuff? Is there a tool that you would use to help you carry things from on the street where it was dropped out to where you needed it? Yeah. So hopefully most of you were thinking of a wheelbarrow by now. Okay, so when you look at the wheelbarrow, the wheel is the fulcrum. Okay, that's the pivot point. In the middle, we have the heavy load. And at the other end, you have to lift it up. So that's the effort. So it goes effort, fulcrum, load, or, sorry, it goes effort, load, fulcrum, ELF, ELF, for second class lever. This also is what a nutcracker is if you need to de-shell nuts. Now I realize most of us just buy our nuts with shells on them, but on occasion, like I've heard of like the Nutcracker for Christmas, that ballet musical. So it's the same sort of thing. ELF, effort at one end. Load in the middle, that's the nut you're trying to crack. Fulcrum at the other. All right. So how are we going to move from a second class lever to a third class lever? Well, remember, we have to keep the fulcrum at one end. So what this means is instead of the load being in the middle as an ELF, we have to move the load to the other end. So, oh, I forgot to mention, example of a second class lever in a human. Okay. So example of second class lever in a human is when you try to stand on tippy toes, okay? Because your body weight is coming down right here through your tibia into your talus, okay? Your tippy toes, or the head of your metatarsals, that is your pivot point. Whereas you are contracting your posterior calf muscles, so that is your effort. So we have effort, load, fulcrum. That's your second class lever. Now, a lot of us don't go around standing on tippy toes unless, of course, we're ballet dancers or doing some yoga move or something. However, perhaps you have seen many a grandparent appeasing a little toddler by bouncing them on their knee. Okay. Every time you are raising the heel of your foot to bounce that child, you are taking advantage of the second class lever. And you should know this because you realize it's a whole lot easier to bounce that kid on your thigh for 20 minutes than to pick up that child and hold that child for 20 minutes. Okay. Now, second class levers are very uncommon in humans. We have a lot of strength without any range of motion. As you know, when you're bouncing the child on your foot, he's going up and down like, you know, an inch. That's it. But it's enough to amuse the child. All right, so now back to our third class lever where we're going to next. We're going to keep our fulcrum at one end, and now we're going to switch the load with the effort. Okay, so hopefully you understand that it would look like this. Any examples of this in your life? Okay. Ladies, how about, and gentlemen who like to manscape, how about some certain things that you do to your face sometimes, or do you like to eat Asian foods without using Western silverware? Yeah, that's right. Both the tweezer and the chopsticks. Okay. Fulcrum at one end, effort in the middle. That's where you're squeezing. Load at the other end. So third class levers, are quite common. Okay. So here is an example of what it would look like. Let's deal with your biceps muscles, okay? Most of your elbow flexors, the elbow is going to be the fulcrum. And by elbow, I specifically mean the trochlea of the humerus with the trochlear notch of the ulna. That's the joint we're talking about. We're not talking because we are talking about a muscle being attached to the forearm. So here we have the elbow joint for the fulcrum. Then we have the muscle attached 1/2 inch to 1 inch just distal to that. And then we have the load that it's moving. So your third class levers are going to be most of your skeletal muscles. Okay. So make sure you understand this. Make sure you totally get all this muscle contraction stuff. Remember, try not to do it in one fell swoop because success is the sum of small efforts that you repeat every single day. You're going to be much more successful if you study 1/2 hour every day for 7 days than if you study 3.5 hours in 1 day. So make sure you know this solid because our next section, which is all about muscle physiology, if you don't understand this, then you're really going to get confused with that. And I will see you again soon. Have a great day.